Everyone, welcome back. In this video, we are going to go over how to curve sketch using the first and second derivatives. So let's take a look at this function here. F of x equals x cubed minus 3x squared plus 2. Okay, so first things first, we're going to go ahead and take the first and second derivatives. So to get the first derivative, I'm just going to use the power rule, and I got 3x squared minus 6x. Then I'm going to take the derivative of that in order to get my second derivative. And again, I'm using the power rule to get 6x minus 6. Now I'm going to go ahead and find the critical points and the inflection points. So again, critical points are where the first derivative equals 0, and inflection points are where the second derivative equals 0. So here's my first derivative set equal to 0. Then I basically just took out my GCF and then solved it by factoring. And that's how I got these two values here. I'm not going to go over that part in depth because that's more algebraic. Next, I got the inflection points by taking my second derivative and setting it equal to 0, which is what you'll see here. And then again, I just use simple algebra to get x equals 1. So these are my critical points and these are my inflection points. Now we're going to have to draw out a sign chart, and we're going to look at what's going on with this function around those 2 points. So I'm going to pick a point to the left of 0 for my first kind of test point here. And then I know x equals 0 is a critical point. I know x equals 1 is an inflection point. And then I know x equals 2 is another critical point. And then let's just pick 3 as my last one. And so I'm going to set up my sign chart like this. So on top, I'm going to put my first derivative value, and on bottom, I'm going to put my second derivative value. So since my critical points were 0 and 2, I'm going to go ahead and plug in those values like that. And let's do the first derivative first, and then we'll move on to the second derivative. So when my x equals -1, I got a positive value for my first derivative. So again, here's the formula if you'd like to just plug that in quickly. But basically I got 9, which is a positive value. When x equals, sorry, I don't know why my x's all got erased. Let me fix that. Okay, when x equals 1, I got a negative value. So let's go ahead and fill that in. So already I'm going from positive to negative, and then when x equals 3, I got a positive value. So I'm going from positive to negative, and then from negative to positive. Now let's go ahead and do the same thing around our second derivative. So we already know pretty much what this function is going to look like just from using the first derivative, but just for practice and so we can put it all together, let's do the second derivative as well. So again, we have an inflection point here, which tells me my concavity is changing. So if we plugged in 0 to the second derivative, we would end up getting a negative number. And I know here it's my second derivative is 0 because that's an inflection point. And then if we plugged in 2, we would end up getting a positive number. So here we do have an inflection point, and it's going from concave down to concave up. So now let's go ahead and sketch a very rough graph of what this might look like. So at 0, I know that I'm concave down, so I don't know exactly what it's going to look like, but let's say it looks like that. And then I know at 1, so let's call this 1, I have an inflection point, so then I'm going to concave up. So let's just say my graph looks something like this. Again, bear with me because obviously I don't know exactly what this looks like, but this does match the correct characteristics that we have from our sign chart, right? So what do we have? At 0, we're going from a positive slope or a positive first derivative to a negative first derivative, right? So we have this relative max here at 0. And we see that as well with the concavity, right? Here to here, this is concave down. Now at 1, we have an inflection point. So we're going from concave down to concave up, like this. And we can also look at the slope there, right? So at 2, which would be right here, we have a slope of 0, and we see that relative minimum value. And then to the right of 2, we have a positive slope or a positive first derivative, right? So that's what you're seeing here with that positive first derivative like that. All right, hopefully that helped. I apologize for my messy graph, but hopefully the concepts made sense. Thanks for watching, and I'll see you in the next one.